Creating strings. The key points given is we need to generate all different strings that can be created using its character. That means we will be given with a string and we need to create different types of arrangement with that string using its characters. So if we are saying that we need to create different type of arrangement, that means we are doing permutation of a string. Permutation means the number of possible arrangement in a set. So arrangements, that's the key thing. So the characters are given, the string is given, and we need to do number of possible arrangements with that character. As an example, cat. So cat consists of 3 characters. That means number of arrangement would possible would be 3 factorial. That means 6. And here are its 6 different arrangement with the string cat. CAT, CTA, ACT, ADC, TAC and TCA. Let's look at this example AABAC. Here we see it is of 2, 2, 4, 5, length 5, and there are 3 repeating characters. That means arrangement of them would give no solution. That means no new solution. A, B, A, C. Let's say this. So if I try to arrange them, so A I will send here and A will I send here. This one A here. So this looks exactly same. So this is no new solution. That's why what we are going to do, we are going to divide that 3 repeating characters with the total number of characters. So total number of characters is 5. So 5 factorial divided by 3 factorial, that would give us 20. And here are its 20 different possible number of arrangements. Let's start to work on the solution to this problem, and for that let's take the example of cat. So we will start here at this point and we will pick the first character, means this one, and we'll start the number of possibilities with this C. So C, then I can go on A, T and can form CAT, or I can go back and instead of choosing A, I choose this T. So T, then the next character would be A, so this will give CTA. Or I can even go back to this and now start working on this A. So this will give A, I can choose C, then T, then ACT. Or I can choose first T, then C, and I can do ATC. Or I can go even back further and I start at this T. So this will give T, then I choose A, C, and TAC, or I can choose C first instead of A. So C, A, and T, A. So TCA. So here there are 6 possible number of arrangements, and let's work on the solution, how we can form a solution. So first of all, you see that we started from here and worked on all possible number of arrangements, then we work on this, then we work on this. So basically we are finding all possible solution. These are all possible solution. That's why we call it brute force. We are applying brute force here to get all possible number of arrangements, and these are all, you can't get any new one. So that's why this is brute force done. Now to get this brute force, what we are doing is we are going back and we are again picking up a different route. I took this route, then I went back and I took this route, then I went even more back and started from here and took this route, so on. So these are all backtracking. We are going back, reconsidering our solution and then coming back. And this backtracking is achieved going back, calling again that procedure. So that is recursion. So brute force is because we are finding all possible number of solution. Backtracking, we are reconsidering the solution, and recursion recursion. To apply this backtracking, we are using recursion. Okay, alright, so let us look at the procedure, how we can proceed. Here is, as an example, cat is taken and I have two indexes, low and high. We'll see what's the meaning of low and high. Actually, this low and high is helping us to scrutinize all possibilities. That means, let's say L and H is here and I is the index. I is the index which is keeping the track of the movement. So since L and I are present at the same location and H is at the last, telling us that this is the end point. So first of all, we are going to swap the low with the I. Actually, low is giving us each possibilities in different indexes, meaning, let's see, so L and I are swapped, so CC will be swapped and no new solution will form, CAT would be there. Now I will move L and also move I. Again swapping is done. Then we have here. Now L is at the position of I. That means you can't go further more. So I will, since L and H are at the same location, I will put this in container. This is one solution got. So this will be kept in our container. This is the first solution. Then I will go back. And we are here at this level. And L and H are here and I is here. What we did? We swapped low with I. We did this. Then we call this function again. Let's call permutation and went back. And then I incremented I. Low is still here. So again low and I swapping will be done, and this is a new solution form. So I will put this in a container, and low, since low is increased here, low is now at here and high is here. So we are going to put this in container. As soon as we hit low and high are together, we will put this in container and we'll go back. After that, we will go back and low and high, like this we were at this level, now we will go back, so we will be at this level. So low and high are here and I is incremented again because I was here, so it will be incremented in the next here. Now again we are going to swap, so L and I will be swapped, so A will go here, C will go here. Then so again I will write swapping is done with low and I, then calling again with low increased and high, I will be here, so swapping will be done again and no new solution is formed. So I will put this in container because at the next low will be here, I will be here, so we'll put this in container. Now we'll go back at this level. Now low is here and I will be incremented, so going back again, and you see when we are going back, I is incremented and swapping is done again, and this is the new solution formed. So we'll put this in container because the next L and H will be at the same position. Now we'll go back again, and while going back we are again swapping the positions, and this will continue. So TAC, and we will get a new TAC, another one will be TCA, and we will put this in container like this, which I told. So let's analyze again. We are swapping we are calling back, and we are again swapping back. How we are again swapping back? Because you see, at this I swapped, this is a new formed, this is the new string now, but on going back I again start with this string. That means we are putting everything back at this place. It is happening at each intermediate steps. So swapping, permutation, calling again, then swapping again, so that this becomes this, and this finally is this, and again we will increment I again. So I can write this. It is going to accept the string low and high, and whenever low and high are equal, we will put the string in container. So that's what container is inserted. The string is inserted in this container. We'll see what is this container. This is just a part of the code written. And if low and high are not equal, we will start I with the low, and will go up till I is less than or equal to high. Swapping is done. Then calling back again with increment of low. So low was here, calling it again with the increment of low. And then this is called, and while this function returns, when the function this function is finished, it returns back. It puts this line, it puts back everything. So let's code this, and there we are going to visualize more. Okay, so the input contains a string of length n. So we'll get this input c in n. This is the string, so it's better to, let's say, call it c s. Then we are going to initialize low. Low will start with 0, and high will be where was high? So high is till the string length. So we'll say s dot length, and yeah, I have not defined the string, so let's initialize this. Now s dot length minus 1, right? Because length will be 3 and 0, 1, 2. So it should be here. Now we'll make a function permutation and from the string the low, the high. And now let's write this function. It accept string as low, high. Here we need to do what? If low and high are equal, that means we need to put this in container dot. Now here what we can use container, we know array, we know vector, but we are not using this because we'll understand here. If I say vector, then this is going to push back, but if we have this type of a string, then what I told, we are applying brute force, so it will give all possible solution. It is going to give all possible solution, but what we need, all possible solution means that A, B, A, C, even the brute force is going to give these arrangement also. That means A is here, this A is here, and this A is here, and but we saw that this is not a no new solution. Hence, this is a duplicate solution of the previous one. So to overcome this, we are going to use set. And what is set? Set stores unique elements. That means it is not going to store the duplicate elements. So it is just like a unique element storage. Hence, we'll define here a globally so that it is available everywhere. Like what we used to do, we used to define first vector and then we used to write the data type. Same also here. We'll say set, define its data type, the container object, and here we are going to store the string. So we'll say string and let's call this name container. So I have defined a string. Why we define a in a string? Because we are going to store the string values, and it's a set because it stores unique values, which we saw here. No new solution. That's why we are going to store unique solutions. And in vector, we used to have push back function. Here we have insert. What we need to insert? We need to insert string s. And if they are not equal, then what we need to perform? We will start with high. We'll go up to. We will start with low. Sorry, it should be low because at the first call, low and high are here only. And this is going to go up to high and it will increment. As explained, swapping, calling, and again swapping to put everything back. So we'll say just simply swap. Swap is an inbuilt function. What we are going to, we will swap low with high. So s of low is swapped with s of high. Swapping is done. Then we will call this function again. And low will be increment. First string s, then low has to go ahead. So I will increment low and high will remain there. And when this is done, put everything back. So we'll say s of low with s of high. So this is our swapping done. Now you also one time just try and run for better understanding. Let's submit this now. And this is creating strings. And showing a wrong answer. So let's see what mistake we have done. Correct output is this, but user output is empty. Yeah, because we have not printed here anything. We need to print also. We have made the container. Now we need to display that container. So what is the display format? Let's see. First we need to print the number of strings formed and then the strings in alphabetical order. So let's display this. See out. We need to print the container size. So we'll say container dot size is a function, and to overcome the compiler warning, we'll typecast to int and we'll leave a line. Now we need to display the container. So like we used to do in vector series, I told you that we can use, we need to create a vector pointer. So here I am creating a set pointer. So instead of writing that big line, I am just using auto. So we'll say container dot begin. So it will put the pointer to beginning, and we need to go till iterator is not equal to container dot end. So till there we need to go and we need to increase the, and here it will display the content of the iterator, content where it is pointing. So the iterator is pointing to the set and that content is print by this and will leave a line. Okay, alright, so let's submit now. Yeah, it's accepted. Alright.